Picture the largest thing you've ever seen: a stadium, a skyscraper, a supertanker. Now imagine something bigger than all of them, floating in the middle of the Indian Ocean, hundreds of kilometers from the nearest coastline, with no road, no bridge, and no pipeline connecting it to land. It processes one of the most volatile substances on Earth. It has been doing this continuously in cyclone-prone waters for years. And it is a ship. The Prelude FLNG is the largest floating machine ever built, and the story of how it exists and why it had to is one of the most extraordinary engineering stories of the last century. To understand why something this extraordinary had to exist, you need to understand a problem that has plagued the energy industry for decades. Deep beneath the ocean floor in remote waters far from any coastline, there are enormous reserves of natural gas. The challenge isn't finding the gas. The challenge is getting it to the people who need it. Traditionally, you'd drill a well, pipe the gas to shore, and process it at a land-based facility. But what do you do when the gas field is hundreds of kilometers offshore, too far from land for a pipeline to be economical? For years, many of these fields simply sat there, untouched and unproductive. The answer Shell came up with was audacious. Bring the entire processing facility to the gas. Don't build a pipeline to shore. Build a floating factory that processes the gas right where it comes out of the ground and loads it directly onto ships for export. A floating liquefied natural gas facility, an FLNG. The engineering challenge was almost incomprehensible. To transport natural gas by ship, you have to cool it to minus 162 degrees Celsius, cold enough to turn it from gas into liquid, shrinking its volume by 600 times. This process requires enormous refrigeration systems, complex chemical processing equipment, and vast storage tanks. All of it in a land-based facility would spread across several city blocks. The Prelude team had to fit it all onto a vessel that could survive 50 years in open ocean conditions, including Category 5 cyclones. The numbers are almost impossible to process. The Prelude is 488 meters long, about the length of 48 double-decker buses parked end to end. Its hull alone weighs 260,000 tons of steel. The total displacement when fully loaded is around 600,000 tons. For context, the largest aircraft carrier in the world, the USS Gerald R. Ford, displaces about 100,000 tons. The Prelude outweighs 6 of them. Construction took place over 4 years at the Samsung Heavy Industries shipyard in South Korea, the only facility in the world large enough to build it. At peak construction, over 7,000 workers were on site simultaneously. The amount of steel used was enough to build 175 Eiffel Towers. The topside processing modules alone, which sit on the main deck, weigh over 130,000 tons. Keeping a structure this size stable in the open ocean is itself a monumental challenge. The Prelude uses a turret mooring system, a massive rotating connection point at the bow that allows the entire vessel to swing like a weather vane and always face into the prevailing wind and waves. This dramatically reduces the forces acting on the hull. The turret is moored to the seabed with a series of huge anchor chains and mooring lines, keeping the vessel fixed in position over the gas field while still allowing it to rotate freely. Below the waterline, the vessel's ballast system manages stability by pumping water between internal tanks, compensating constantly for the weight of cargo, equipment loads, and changing sea states. The Prelude operates in the Browse Basin, about 475 kilometers northeast of Broome in Western Australia. This is remote, difficult ocean, prone to cyclones and far from any major port. In the event of an extreme weather event, the vessel is designed to disconnect from its mooring and move to safer water, then reconnect when conditions improve. The mooring reconnection system alone is a feat of precision engineering, threading enormous chains back through the seabed anchors in conditions that are rarely calm. Once gas is extracted from the wells below, it travels up through flexible risers to the vessel, where it goes through a multi-stage processing train. Heavier hydrocarbons like condensate and LPG are separated out. Then the remaining gas is cooled through multiple refrigeration cycles until it liquefies. The liquid gas is then stored in 4 enormous cryogenic tanks within the hull, each capable of holding tens of thousands of cubic meters at minus 162 degrees. Shuttle tankers pull alongside, a process called ship-to-ship transfer in open ocean, and the LNG is offloaded for delivery to markets across Asia. The entire operation runs 24 hours a day, 365 days a year, largely automated, from a vessel in the middle of the ocean. What makes the Prelude especially significant is what it represents for the future of energy. There are remote gas fields all over the world that have been stranded for decades, too far from shore to develop economically. FLNG technology changes that equation entirely. It opens up a new category of resource that was previously unreachable. The Prelude FLNG isn't just the largest floating machine ever built. It's a proof of concept, evidence that human engineering can project industrial capability into some of the most remote and hostile places on Earth. It floats, it processes, it delivers, and somewhere out in the Indian Ocean right now, it's doing all three at once.